Hello everyone, I'm Shai Chaoshan. Let's continue with the 10th grade must-know series. Today we're looking at even and odd functions related to logarithms. Logarithmic functions themselves aren't even or odd, but composite functions involving them can be. Let's take a quick note of their characteristics. For an even function here, we have a function y equals log base a, and for the argument, we have it to the power of some multiple of x. I'm not exactly sure how many times x, so let's say lambda times x, then plus 1. That's our argument. And then we subtract 1/2 of lambda x. This function is an even function. This means as long as we remember this general characteristic, the characteristic it has is that the base of the logarithm and the base of the power in the argument are the same. Then the exponent of that power is lambda times x, and the coefficient of the linear term that follows is negative 1/2 of lambda negative 1/2 of lambda. Negative lambda over 2 is all you need. Okay, and moving on, let's take a look. It also has another one called an odd function. Now, for the odd function, the characteristics we find here, there are two common cases. One is y equals log base any a. Then under the square root, lambda squared x squared plus 1, then either plus or minus lambda x. This function is always an odd function. It's always an odd function. Plus or minus doesn't matter. That means you must remember the characteristic, the base doesn't matter. The argument is the square root of something plus or minus something, and that something is just the square root of lambda squared x squared. So lambda x. Plus or minus both work. Okay, another one is y equals log base a of, we often see x minus lambda over x plus lambda, or lambda minus x over lambda plus x. Both are fine. Or you can swap the numerator and denominator. Either way works. Y equals log base a of x plus lambda over x minus lambda. This structure is what an odd function looks like. Just remember it roughly. Okay, so this means the first function is an even function. For an even function, once you find that the bases are the same, then the coefficient of the exponent here, half of it with a negative sign, is the coefficient of my linear term. So we can quickly find that the value of k is negative 1/2. Okay, good. So for short questions, just use this quick logic to solve them. For long questions, well, you can verify it by checking if f of x equals f of negative x. All right, let's try a quick one. Remember the features. Since the whole thing is an even function, and it's multiplied by x, which is an odd function, it means the right side must be an odd function. And the odd function related to logs is log base a of the square root of lambda x squared plus 1 plus or minus lambda x. So here, since yours is a, it means a is just 1. Okay, next, it says if a equals 1, then this thing is an odd function. So when a equals 1, it's log of 1 plus x over 1 minus x. No problem. That proves it's an odd function. But if it's an odd function, this a here could also be negative 1. So x minus 1 over x plus 1 works too. So if it's an odd function, note that for this a, the value can be plus or minus 1. This means the implication goes one way, but not the other. It's a sufficient but not necessary condition, so we pick option A. That means when you see this kind of log-related parity test, everyone, make sure you get these points. It might be in the short questions, or it could be the background for the first part of a long question.